Good morning, students. So today I am come with a new topic, new paper. That is Introduction to Data Structures. Means in this data structure using C. In this paper, I am going to discuss about different concept, basic concept of data structure. So first, in this class, I just want to discuss what is data structure and what are its different categories. So first, what is data? So data, the collections of raw fact or raw entities. So data structure is representations of the logical relationship existing between individual elements of data. The data structure is a for specialized format for organizing and storing data in memory, which considers not only the elements stored but also their relationship to each other. So data structure affects the design of both structural and functional aspect of a program. So program, we know what is program. Program is a set of instructions. So even to computer to do some special job. So program is equal to, again, if we see in the programming concept, then program equal to algorithm plus data structure. So program is consist of data structure with algorithm. So we know that algorithm is a step-by-step procedure to solve a particular function. So now classification of data structure. If we see how data structure are divided in different categories, then data structure are normally two categories: primitive data structure and non-primitive data structure. So if we see the details of different types of data structure there we are going to discuss here. So data structure is two broad categories: primitive and non-primitive. So if we see primitive, so here integer, character, float, pointers, these are data types. Again, if we see non-primitive data structure, shows arrays and list. So this is linear data structure. So arrays, single dimension, two dimension, multi-dimension. Similarly, list may be either linear or non-linear. So if we see the list linear, then stack, queue, linked list. Non-linear data structure, trees and graphs. So first, what is primitive data structure? They are basic data structure and directly operate upon by the machine instructions. So this type of data structure is known as primitive data structure. So fundamental data types also, if we say also it is the fundamental data structure. So data structure that are directly operated upon the machine level instructions are known as primitive data structure. So integer, floating point number, character constant, string constant, pointers for in this category. So primitive data structure, the most commonly used operations on data structure are broadly categorized into following type: create, selections, updating, delete or destroy. So non-primitive data structure, they are more sophisticated data structures. The data structure which are derived from the primitive data structure or combined from the which are constructed combining two or more primitive data structure are called as non-primitive data structure. So non-primitive data structure emphasis on structuring of a group of homogeneous, same type or heterogeneous different type data items. So non-primitive data structure, linear data structure. So linear data structure kind of data structure which has homogeneous elements. So data structure in which elements are in sequence and form a linear series. So linear data structures are very easy to implement since the memory of the computer is also organized in linear fashion. So some commonly used linear data structures are array, stack, queue, linked list, etc. So nonlinear data structure. A nonlinear data structure is a data structure in which data item is connected to several other data items. So nonlinear data structure may exhibit either a hierarchical relationship or parent-child relationship. The data elements are not arranged in a sequence structure. So the different nonlinear data structure are trees, graphs, etc. So non-primitive data structure, the most common use operations on data structure of non-primitive type are broadly categorized into following types: traversal, insertion, selection, searching, sorting, merging, destroy or delete. This type of operations you can apply it with the non-primitive data structure. So difference between them. A primitive data structure is generally a basic structure which is usually built into the language such as integer, a float, a character, etc. A non-primitive data structure is built out of primitive data structure linked together in meaningful way or combine the primitive data structure to for a meaningful structure such as linked lists, arrays, binary search tree, AVL tree, graphs, etc. So description of various data structure. Array is defined as a set of finite number of homogeneous elements or same data items. So it means an array can contains one type of data only. For example, either all integers, all float point number of all characters, etc. So one-dimensional array. An array with only one row or column is called one-dimensional array. It is a finite collection of n numbers of elements of same type such that can be referenced by indexing. The syntax and element are stored in continuous locations. Element X to define one-dimensional array is, suppose syntax is data type, array name and size, where the type of value it can store. For example, integer, character, float, array name to identify the array, and size the maximum number of elements that the array can hold. So array simple declaration of array is as follows: integer array 10, where integer specifies the data types or types of elements array stores. ARR, that is the name of array, and address, the number specified inside the square bracket, is the number of elements an array can store. That is size of the array is 10. This is called also size or length of the array. Now representation the a linear array in memory. How we can store, how we can how array is stored in memory. If we see, the elements of linear array are stored in consecutive memory locations. So it is shown below. So linear array A, this is the index 1, 2, 3, 4. So these are this address. So if we 1000 starting the basic, this is 1000. So next 1000 to 1004. If we store here integer values, so its size is 2 bytes. So the address is varied by increment by 2 bytes. So suppose these are the elements we stored in this array values. So in this way you can store the values in array in memory. So address are in bytes. Now the array, the elements of array will always be stored in consecutive continuous memory locations. The number of elements that can be stored in an array, which is the size of the array or its length, is given by the following equations. So upper minus lower plus 1. So this is the size of the upper bound minus lower bound plus 1. That means the size of the array. So if, for example, for the above array, it would be 9 minus 0 plus 1, 10, where 0 is the lower bound of the array, 9 is the upper bound of the array. So array can always be read or written through loops. So for, if we see in this here, just we take a for loop and scan and print this way. This is the syntax of C programming. So arrays type single dimension array, array with one subscribe, two dimension array with two subscribed rows and columns. So multi-dimension array with multiple subscribes. So basic operations of arrays. Some common operations performed on arrays are traversing, searching, insertion, deletion, sorting, merging, etc. So traversing arrays. How we traverse array? Traversing, it is used to access each data item exactly once so that it can be processed. So suppose we have a linear array A 1, 2, 3, 4, this the index, and 10, 20, 30, 40, 50 these values. Then we can store in this way. So here we'll start from beginning and we'll go still last element, and during this process we'll access value of elements exactly once. So array 1, so 10 is stored in array, actually in some case it is A0, so first locations of the array. So 20 is stored in second locations. In this way you can store. So if we see the algorithm traversals, here traversal is a function of three parameters: array, lower bound, upper bound, array, lower bound, and lower. So step from locations lower bound to upper bound, process L locations, and end. This way you can, the algorithm of traversals you can discuss, you can see in this way. So insertion to array. Now insertion, it is used to add a new data items in the given collections of data items. So we have a linear array. Suppose this is 1, 2, 3, 4, 5. So 10, 20, 50, 30, 15 are stored. New elements to be inserted 100 in the locations of 3. Then so shift the elements from fifth locations to third location downwards and by one place, and then insert 100 at third locations. This algorithm, if we see, this is the original array. Now we shift the elements 30, this 30, 50, and then we have a space here, then 100 is inserted here. So for insertion algorithm, we have three parameters: array, number of elements, and item to be inserted, and position where elements is to be inserted. So is an array with an element, item is the element to be inserted in the position post. So first step we see actually shifting the elements to find the position. So for that integer, we have loop, taking loop from the last two positions. So for loop n-1 down to post, and we shifted each element adding one place. So ai is equal to ai plus 1. So in loop n, the space which is blank, so item is placed in the a post, and finally the size of the array is incremented. So in this way we have the algorithm of insertion. Now if we see how delete the elements from the array. So deletion, it is used to delete an existing data item from the given collections of data items. So for example, let F4 is an array with 10, 20, 30, 40, 50 consecutive locations. So this is an array with 5 elements. So suppose 30 has to be deleted at the position 2. So this procedure is applied: copy 30 to items at 30 items, then move number 40 to position 2 and move number 50 to position 3. So in this way we take away the elements which is stored in 2 and these are actually shifted above in this list, and finally we delete the elements. And the algorithm, if we see here, we also delete operations. So array total size item to be deleted and positions. A is an array with an elements. Item is the element to be deleted in the position pause and stored in the variable item. So step 1, firstly we identify the item to be deleted. So a pose is item. So item of the elements to be deleted is keeping in item. So for I, from I pause down to n minus position from the end of the array, so shifting is done. So actually one place element is shifting the this a I plus 1 is to there. So till and the loop we shifted the elements and we have an array is decremented. This procedure gives the deletion of elements. Now searching in the array, it is the technique which is used to find out the location of the data items if it exists in a given collections of data items. So we have linear array this 1 2 3 4 5 and placing elements at this. So suppose item to be searched is 20. So 20 to be searched, then we actually will start from beginning which compare to 20 which element, and this process continue until the element is found or array finished here. So comparing with each other, we have found the position 4 where 20 is stored. So linear search. So I think this will be the next one important class. So today I stop here. Thank you.